Hydrogen, the fuel of the future. Hydrogen is the fuel of the future which could help end the world's dependence on fossil fuels and aid the transition to net zero emissions. According to certain estimates, hydrogen will contribute 22% of the global energy requirements by 2050. Hydrogen has a very high energy density of 142 megajoule per kg, hence it is much more cost-effective energy carrier than synthetic fossil fuels. Aim: to study various methods of hydrogen generation and find a suitable process to produce hydrogen fuel from renewable resources. Objective: conventional fossil fuels are the major contributors to the greenhouse effect and global warming. Finding viable and sustainable alternative fuels is a critical priority. Hydrogen fuel is an excellent alternative to reduce our dependence on fossil fuels. Hence, we worked on this problem to find the best methods of producing renewable hydrogen. Electrolysis of water. In this experiment, we have taken a 9-volt battery and connected it to the electrode using copper wires. The red wire is connected to the positive terminal of the battery and the black wire is connected to the negative terminal of a battery. The other end of the wire is tied around graphite rods, which are 2 mm pencil leads. To prepare the electrolyte, we took some distilled water in a beaker and added potassium hydroxide into it. It is stirred well till it dissolves completely. Then it is poured into a tub. 2 test tubes are filled with water and the electrodes are inserted into it. These test tubes are then inverted into the tub containing the electrolyte. To keep the test tubes in place, we fixed it using cardboard and some tape. The reaction begins immediately. Since the water molecule has 2 hydrogen atoms and 1 oxygen atom, the amount of oxygen produced will be half when compared to hydrogen. The gases produced in this reaction displaces the water in the test tube. Oxygen is produced at the anode, which is connected to the positive terminal of the battery by red copper wire. Hydrogen is produced at the cathode, which is connected to the negative terminal of the battery by a black copper wire. To check for the presence of hydrogen, a burning splint is introduced near the mouth of the test tube containing hydrogen. A squeaky pop sound confirms the presence of hydrogen. Production of biogas. Biogas predominantly consists of methane. It is produced by anaerobic fermentation of biodegradable waste like cow dung, fruit and vegetable peels, etc. A slurry is prepared and filled in a 5-liter bottle and the top of it is crushed. The bottle slowly regains its shape as it gets filled by biogas. The fermentation process takes around 6 weeks. To test for the presence of methane, a burning matchstick is bought near the needle. Displacement of the flame confirms that methane is present. Hydrogen production unit. We designed a miniature model which represents how hydrogen can be produced from methane. In an industrial setup where a high temperature of 1000 degrees centigrade can be maintained, methane undergoes decomposition to produce hydrogen. The catalyst used is nickel nanoparticle decorated graphene supported on ceramic or porcelain beads. In the first step, methane is passed from anaerobic digester to reactor 1. Here, gases like hydrogen sulfide and carbon dioxide are removed. Hydrogen sulfide is toxic to the nickel graphene catalyst used in the process. The temperature in reactor 2 can be controlled by a thermocouple. From reactor 1, methane goes to reactor 2 where it is heated to 1000 degrees Celsius. This heated gas moves to hydrogen generation reactor. Here, a catalyst surface reaction takes place with the nickel graphene catalyst. The hydrogen produced in the hydrogen generation reactor is collected in this collection unit. Instead of methane, we can also use ammonia, water, etc. to produce hydrogen in a similar production unit. Conclusion: hydrogen fuel generated using renewable energy instead of fossil fuels has the potential to provide clean source of energy whose byproduct is only water. With this project, we tried to come up with a contemporary solution which can replace the conventional energy sources and be hailed as green energy, which fuels a future devoid of environmental issues. Hydrogen has various applications, such as in aerospace industry as a fuel for subsonic and supersonic aircrafts, spacecraft propulsion, pharmaceuticals, glass purification, welding, and semiconductors manufacturing. Other important applications include hydrogen vehicles, synthetic fuels, power generation, heating, metal refining, ammonia fertilizer, etc. Thank you.